Hello, mentors. Welcome to meeting 6. So this is separation part 2 on November 13th. And being a part 2, of course, this is a follow-up to meeting 5, in which you explore the topic of segregation and dynamical systems. So here we pretty much have the same mathematical ideas, but now we make more emphasis in models and parameters. So last meeting, we also used models and parameters, but it was not very visible or very explicit. The idea in this meeting is to use these words and their meanings because students are making models and deciding on parameters. Along the way, of course, making conjectures as well. So they'll have more freedom than last week to explore. And then it's the same topics, and you can go deeper into segregation, racism, systemic inequity, and just communicate with your students. You already know their interests and all the stories they've told you, just to go deeper in that sense. It's a bit strange of a meeting in terms of the agenda, so a little different because we'll have 3 main activities. But yeah, let's say the first one, it's very similar in style to last meeting, so it's called square grids. And then after the break, we'll do some presentations. And finally, we'll do the professions panel or exchange. And this should be actually, 15 minutes. Or depending on your table and your LAs, they can give a little more priority to this part, the exchange, or to the presentation. So we'll talk a little bit more in a bit. So a square grid, we'll do the following 2 things. First, we'll talk about the grid itself, and then we'll do free explorations. So let's see how this looks like. So this is the main part of the meeting, of course. So in square grid, we start with this very similar presentation to the one last week, but now it's a big square grid. We have 36 spaces, right? And we'll put roughly even number of squares and triangles. We'll have a tolerance limit as our parameter. And you can play around, maybe start with the 51%, or if your students are up to it, you can play with other values. And so this should be done together as a demo, so that everyone can see what's going on. We'll have big chessboards of 8 by 8, just cover 2 rows and 2 columns to make it 6 by 6. So you'll take turns and stop when all shapes are happy. We'll have these fraction conversions because now, as you can see, we have up to 8 neighbors in some cases, right? So for example, these would have 7. And so you would have to make computations of 7ths. So this would come pretty handy here, knowing that it's 14.2 each time. So this would be 28.4, right? 2 7ths in terms of computing the tolerance, the threshold for happiness or unhappiness. So that's the first part. And then the main part, it's explorations or investigations, in which you're presenting the students with 4 different explorations. And they should be really feeling like something open, that there's no solution in the teaching guide, or you're not telling them the answers or checking, but it's more they're actually creating knowledge. So that's how it should feel. And you also, as a mentor, will investigate during the meeting with them. So be part of a team, make it very horizontal in that sense, that you're really collaborating as mathematicians or as investigators. So the first model is to add 1 more shape and see what happens if you get more separation, less separation, or really the same. And also they have to decide on the parameters. So the tolerance here, they have to think and say if it's going to be larger or smaller than in this other normal model where you had these levels of tolerance. So they'll have to think about what's the effect of having more shapes on what would be better for tolerance, so that this model doesn't go to separation too fast or so. The second, it's called inverse grid. So it's pretty fun. You just put the shapes in the intersections of the grid. So now you actually would have this triangle line here, for example. And so what happens is that you get 4 neighbors instead of 8 neighbors. So that should be a realization. And it's not a 6 by 6 grid, but a 7 by 7, because you have 7 per row, right? 7 possibilities, and you have 7 rows, so 49 shapes. So they should be figuring that out. So instead of you telling them as a mentor, all these consequences, right? All these things that follow up from the first specification of the model, they should be making those conclusions. So mini aha moments for them. So that's the second exploration. The third is called an absolute value. So it's getting rid of percentages and relative conditions for happiness, like 70% of my neighbors, things like that, and just go simpler with this rule. I'm happy when 2 or more neighbors are like me. Even if I have 3 neighbors, even if I have 8 neighbors, doesn't matter. That's irrelevant. I just want 2 friendly people like me, and the rest, I don't really care. Here, an interesting question would be if this model is less realistic or more realistic than the relative model. So you can think about life situations for neighbors and, schools and all sorts of places to see if this makes sense. The fact that happiness is kind of predicted mostly for people just with an absolute value of neighbors. Of course, in real life, maybe it's not 2, but maybe 3 or 4, doesn't matter, but absolute, not relative to how many neighbors you have. And I think it's an interesting discussion, and you could have several takes. So it should engage kids into going back to real world and not just stay in this abstract simulation. So that's also very important. The final, and probably, more involved, I wouldn't say harder, because all of them can be, very deep. It's called 2 different tolerances, where you make this asymmetric, non-symmetric, and one group is more tolerant than the other. The other is less tolerant. So for example, one shape with 51%, the other with 71%, and see what happens. Students could come up with another exploration, but make sure that it's well-defined and it leads to some testing, that it's not too vague. Or they could even mix. For example, they could mix more company along with the inverse grid to see what happens, or they could mix absolute rule together with more company and try to see what happens. So that's part 1. Second part will be led by your LAs, but you will also participate in the sense that you can tell them during the monitoring, during part 1, which groups could present. I mean, it's all about the students deciding, but some of the groups will present their projects or their investigations to the whole room. So this is sort of like a math circle style, where after or at the end of the meeting, students present what they did, all the questions they answer, and the things that they were not sure. And there's a back and forth with questions and answers. Little thing, maybe in your room, the LAs decide, instead of doing presentations, having the tables keep working on this if the investigations are, really cool and the students seem to need more time. So there's some flexibility there, but otherwise they could close this with presentations. And the final part is the professions exchange or panel, which will be also led by the LAs, but your mentors will be the main, the main speakers here. So you can fill this form, these Google Forms, to let us know of questions that you would really enjoy answering or asking to other fellow mentors. So please consider volunteering, and we hope a big participation from you guys. The goals for this panel are expose students to different professions and jobs. Remember that in Math.co, even beyond the math, our goal is to capture students and have them, realize that going to college, it's a very good choice. Have students think out loud about their dream jobs and sequence of steps to get there. So start thinking about that, even if they're middle schoolers. And finally, have students learn more about personal stories from you mentors. So I hope you enjoyed this meeting a lot, and see you in the next video. Goodbye.